You cradled the phone to your ear, and the low hum of a voice emerged, 120 hertz, vibrating through bone and air. But for a moth, that same sound is not a conversation. It is an earthquake. Somewhere in a meadow, a greater wax moth feels a frequency so high it has no equivalent in your world, a pitch at 300,000 cycles per second, and its brain translates that vibration into a shape in space. That moth does not hear color exactly, not in the way a human synesthete sees a trumpet blast as deep purple, but it lives in a sensory ocean so foreign that the closest your language has is the phrase itself. The animal that can hear colors lives right beside you. You have just never known how to listen. About 4% of people on Earth experience a phenomenon called synesthesia. A sound arrives and a color blooms unbidden in the mind. The number has been stubbornly consistent across decades of research. 4%. A genetic glitch in how neurons find their partners during development, wiring the auditory cortex to the visual one in a way no one fully planned. But that is a human brain, reconfiguring its own architecture. What happens when an entire species evolved from the ground up to do something similar, something your neurology cannot reproduce at all? The greater wax moth, Galleria melanella, hears at frequencies your eardrum has never moved for. 20,000 hertz is your ceiling, the high whine of a mosquito at dusk. 300,000 hertz is where this moth operates, a realm of sound your body cannot detect, cannot feel, cannot even register as existent. And when those ultrasonic pulses strike its tympanic membrane, it does not simply hear them. It orients, it dodges, it weaves through the dark as if it can see the bat's sonar beam, which, in a sense, it can. Now here is where it gets strange. The bat emits its cry at frequencies near 100,000 hertz. The moth hears that cry, and the moth's ear converts that sound into precise spatial information. The moth does not just detect the predator, it reconstructs the predator's position, distance, and trajectory from sound alone. That is not hearing as you know it. That is hearing that functions as vision. The moth hears a shape. So, pause on that. What the moth does is not analogy. Its brain transduces air pressure into a spatial map your own neurology cannot produce. If you want to keep tracing these hidden sensory borders, subscribe to the channel so you do not miss the next layer of evidence. And in the comments, tell me, would you describe what the moth experiences as hearing, as vision, or as something that needs its own word? In 2024, researchers studying the genetics of synesthesia at the Smithsonian identified 6 genes that seem to govern how neurons connect to the correct partners in the brain. 6 genes that, when altered, allow sound to paint the visual field. But the moth's system is not a handful of miswired genes. It is an entire sensory apparatus shaped by tens of millions of years of predation. The bat screams, and the moth hears a 3-dimensional map. The bat's cry is a brush, and the moth's brain is the canvas. The question that no one answers cleanly is whether that counts as color. Because color does not really exist. It is not a property of light. It is a translation your brain performs. The wavelengths that hit your retina are converted into electrochemical signals. Your cortex assigns them names. The sky is not blue. Your brain paints it blue. The moth's brain paints with sound. You walk through the world with a limited palette. 3 types of cone cells, sensitive to red, green, and blue. That is your entire visual vocabulary. Some animals carry 4 cone types. Tetrachromatic vision, the scientists call it. The mantis shrimp carries up to 16 photoreceptor types. 16. It sees a world so densely colored that you cannot even approximate the experience in imagination. But the moth is not using photoreceptors to see. It is using tympanic membranes. It is painting its visual field with air pressure. If you have ever been in complete darkness and felt a draft on your skin, you experienced a ghost of this. The air moved, and your brain built a spatial impression from that movement. Now multiply that by a factor of 10,000. The moth lives in darkness, and the darkness is not empty. It is full of shapes drawn in ultrasound. The bat's sonar beam is a narrow cone of high-frequency pulses. The moth's ear is specialized to detect those pulses at extreme distances. Some estimates suggest the greater wax moth can register bat cries from over 30 meters away, in absolute darkness, in a cave, in the middle of a forest where you would be blind. That is only half the story. The moth does not hear passively and panic. It has evolved its own countersinging. When it detects a bat in its sensorium, it produces high-frequency clicks of its own. Those clicks jam the bat's sonar, creating noise, blurring the shape of the moth in the bat's acoustic image. The moth becomes invisible by making itself louder. You cannot hear that battle. It happens above 20,000 hertz, beyond your threshold. The meadow is silent to you. But above your head, in a frequency band you will never access, a war is being fought with color. The moth hears the bat as a streak of approaching red. The bat hears the moth as a flickering void. Both of them navigate a world of sound that is functionally visual. And here is the part that pulls the floor from under your feet. Your dog lives in a similar divide. Dogs see a range similar to human red-green color blindness, a world of muted browns and yellows. But their hearing reaches 40,000 hertz, almost double your ceiling. Your dog hears the high whine of a distant rodent, the flutter of a beetle's wings at 25,000 cycles. Your dog does not hear colors the way the moth does, but your dog hears a world your senses cannot confirm exists. Every time you call its name and it does not turn, you assume disinterest. That assumption is wrong. It may have heard a frequency you cannot, a sound so high it pulled its attention away from you. You live in a sensory prison and do not know the walls exist. The human hearing range is roughly 20 to 20,000 hertz. That is your universe. The greater wax moth lives up to 300,000 hertz. Infrasonic sounds, the rumbles below 20 hertz, are what elephants use to communicate across miles, and you never feel them. Your own planet hums in frequencies you cannot perceive. And yet, you have the audacity to look at your cat staring at an empty wall and wonder what is wrong with it. The cat is seeing a frequency of light that your retina does not process. Ultraviolet. Birds see it. Reindeer see it. The cat sees a world where the wall is not blank, but stained with patterns of reflected light invisible to you. The cat is not crazy. The cat is tetrachromatic. You are the one missing a sensor. Every time you assume your pet's behavior is random, you are projecting your own sensory blindness onto a creature that navigates a richer reality. If you want to keep unearthing these hidden channels, subscribe. This channel exists because the world is not as simple as it appears. And in the comments, share one moment when your cat or dog reacted to something you could not detect. What do you think they were sensing? The moth is the cleanest example because it collapses the boundary between senses. It does not merely hear well. It hears so well that hearing becomes sight. That is not poetry. That is what the data shows. When a bat's cry hits the moth's ear, the moth's flight muscles contract, its wings tilt, its body rotates. The entire response is instantaneous, spatial, and visual. If you could plug your brain into a greater wax moth for 1 minute, you would not experience sound. You would experience a flash of shape, distance, and motion, all resolved in darkness, all drawn in frequencies you cannot conceive. You would taste what it is to be a creature for whom the hidden world is the only world. The greater wax moth hears colors. You cannot. And you will never know what you are missing. That sensory confinement is not a flaw in the design of your ear. It is an adaptation. Your ancestors traded ultrasonic range for the ability to hear a baby's cry across a crowded camp, to parse the nuance of vowel and consonant that builds language. You hear the difference between a warning and a joke at 2 meters. The moth hears the shape of its death at 30 meters. Neither perception is superior. They are just different agreements with the world. But that difference matters now, in this moment, because it forces you to ask a question that has no comfortable answer. If an animal living in your own backyard experiences a reality you cannot even simulate, how many other worlds are overlapping with yours right now? How many conversations are happening in frequencies you will never access? How many colors are painting the air around you and you walk through them blind? Those questions are not rhetorical. They are the starting point for a different way of moving through your own home. If you want to continue this investigation into the sensory multiverse you share with every animal around you, subscribe now so you do not lose the thread. And in the comments, tell me, if you could borrow one animal's sense for a day, the moth's ultrasonic vision, the cat's ultraviolet sight, the dog's extended hearing, which would you choose and why? The greater wax moth does not know it hears colors. It has no name for what it does. It simply orients, dodges, lives, and dies in a sensorium so far beyond your own that your language breaks trying to describe it. The moth does not feel sorrow about your deafness. It has no concept of your limitation. But you have a concept of yours now, and that knowledge changes something. You will never hear a frequency above 20,000 hertz. You will never know what the wall looks like to your cat. You will never taste the bat's sonar as color. The boundary is permanent, drawn in bone and neuron, hardened by millions of years of evolutionary trade-offs. That is not a tragedy. It is a fact. But it is a fact that should make you hesitate the next time you assume your pet's world is a smaller version of yours. It is not smaller, it is different. And that difference is not a deficit. It is a window into a universe that has been running alongside you the whole time, invisible, inaudible, and undeniably real.